Hi everyone, we're going to go over the Unit 8 mid-unit assessment. So the first one, it was talking about a bag containing 6 marbles. One of the marbles was blue, the rest were red. If one marble was drawn from the bag, it is what that it will be blue? Well, I know that 1 out of 6 total marbles is blue, so it's not impossible, it's not certain, and it's definitely not likely, so it should have been unlikely. Eleanor is randomly choosing pairs of socks from her dresser. She has 6 pairs of white, 8 pairs of black, and 14 pairs of gray. So that means she has a total of, 28 pairs of socks. It is less likely that Eleanor will choose a pair of gray socks than black. Well, she has more gray than she does black, so that would be false. It is more likely that Eleanor will choose a pair of white socks than gray. White, well, that's also false because she has more gray. The most likely outcome is that Eleanor will choose a pair of black socks. Well, that's not true because she has 14 pairs of gray. The least likely outcome is that she will choose a pair of white socks. Well, that's true because she has the least amount of white, so that would be true. All right, Margaret will spin the spinner below 500 times. About how many times is the spinner expected to land on a multiple of 3? Well, a multiple of 3 would be 3 and 6. So that's 2 outcomes out of 6. So we have our favorable outcomes out of totals. So that's 2 out of 6. Or I could reduce it if I wanted to, and that's 500 outcomes. So I'm going to divide by 6. I'm going to get 0.3 repeating times 500. So in my calculator, I'm doing 0.3 repeating times 500. And I get 166 2/3. So it says which one would be the most likely? It would have been B. Jacqueline gets hit 40% of the time. She is going to use colored tiles to simulate her chances of getting a hit. Green tiles will represent the hits. Red tiles will represent the times that she does not get a hit. She will place the tiles in a bag and draw the tiles from the bag one at a time. Jacqueline places 12 green tiles in the bag. How many red tiles should she place in the bag? Well, I have I have green and red. I know that 40% of the time, and so that means 60% of the time she does not get a hit. If she's going to do 12 green tiles, that would mean she's multiplying what by a factor of 3. So right? So I would need 18 red tiles. Gary rolls a fair number cube with 1 through 6 100 times and records the results in the table below. What is the experimental probability of not rolling a 3? So not rolling a 3. So if I got a 3 18 times, that means that 82 out of 100 times I must have gotten something else. So it said in the simplest form or as a decimal, so I could have gone 0.82, or I could have said, 41 over 50? Either one would have worked. All right, if a standard coin is flipped 3 times, what is the probability it will land on heads each time? Well, it has a chance to land on heads the first time, the second time, and the third time. So it would equal 1/8. Or you could have drawn out a tree diagram and then for the third flip, so this represents the first coin. This represents the outcomes on the second coin. And this represents the outcomes of the third coin. So there's 1, 2, 3, 4, 5, 6, 7, 8 outcomes on the third coin. And of those outcomes, only 1 out of the 8 is heads. Place the correct word next to the column. So how likely is it to get a 3? So there's 1 3 out of 8 possible outcomes, so it's unlikely. A 9 would be impossible. A number less than 7, well, that would be all of these, so that would be pretty likely. And a number less than 10, well, there's no number greater than 10, so that would be certain. All right, in the diagram, they want you to choose all the options that show one flip landing on heads and the other 2 flips landing on tails. So 1 heads and 2 tails. So those are the 3 you should have chosen. Okay, he spins the spinner twice. What is the probability he will get green both times? So that's 1/5 times 1/5 would be 1/25, right? So 1/25, and if I want to get to 100, I'm going to multiply by 4. So that would be 4 out of 100%, so that would be 4%. All right, Frank has 9 tiles in the bag. Frank will pick 1 tile from the bag at random, then he will pick a second tile without replacing the first. Oops. So what is the probability he'll pick 2 yellows? Well, he has 2 yellows at the beginning out of 9. Then if he's holding one of the yellows, he only has 1 yellow tile left out of 8. So I'm going to reduce this before I multiply. So I get 1/36. All right, 2 friends claim their towns received more snow. They want you to choose all the true statements. So the first thing I'm going to have to do is put these numbers in order from least to greatest. And then I'm going to put these numbers in order. All right, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I've got 10 numbers. So it says the median is greater for town A. So let's check 1, 2, 3. This would be 4.5. And that's not true because it's greater for town B. The spread of the data is the same for both towns. Well, 10 minus 0 is 10. 12 minus 2 is 10. So that's true. The interquartile range. So I've got to find the interquartile range. So 4 minus 0 is 4. And then that's 6. The interquartile range is less for town A than town B. Well, that's true. The modes are the best representations of the data in both towns. Well, that's not true because the mode's never the best representation. The mean number of inches of snow was twice as much in town B as it was in town A. Well, let's check the mean. So I've got to add them up. I get 6.3, and then $2.7. So I'm going to divide the two. So 6.3 divided by 2.7, I get 2.3. So the mean number of inches was twice as much in town B as it was in town A. So it's about twice as much. Let's check to make sure I did that right because it looks pretty close. And then it's pretty daggone close. I would say that it is E because, I mean, it's so close. All right, for this one, it says the scientists have all this information. They repeated the procedure for 50 type B monkeys and type A. The data showed the weight of the type A monkeys was in general higher than the weight of the type B monkeys. So the weight of the type A monkeys was in general higher than the type B monkeys. So this one shows it. This one shows it. This one shows it. Okay, so there were 3 of them that showed that the weight was higher in the type A monkeys. So even though this one was close, it still shows that in general the weights were higher. So I think maybe that was the one that everybody kind of missed, was this one right here. Because a lot of you got partial credit for that one. So kind of think about that. All right. For the next one, it says a local middle school, they were doing a can drive and they wanted to know some information. So we're looking at the range and the interquartile range. So we have 10 and 1, so we know that's 9. And we have 7 and 2, and we know that's 5. So the range for 6th grade was greater than 7th. So we know that we can eliminate B, and we can eliminate D. So then we're going to look to the interquartile range. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 1, 2, 3, 4, 5, 6, 7. So that's our middle dot because we have 1, 2, 3, 4, 5, 6, 7. 7 dots before and 7 dots after. So that means 1, 2, 3. 1, 2, 3. Oops, no. 1, 2, 3. Okay, so 7 minus 2 is 5, so that would be our IQR. And then for this one, we would have 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3. So we would do 6 minus 3, and we get 3 as our IQR. All right, so it says this, and the interquartile range for 6th grade is greater than the interquartile range for 7th. That's true. So A should have been our answer. All right, how much greater is the interquartile range in the women's ages than that of the men's? Well, we know that we're doing 36 minus 26. So we should have 10. And then 38 minus 30, which is 8. So it's 2. All right, the mean absolute deviation. So we're going to add up these numbers and divide by how many numbers we have. So 650, 525, 575, 675, and 6, and divide by 5. So we got 605. So then we subtract each one, so it's 45 cents. But really, I should double check my mean. So 650 plus 525, because if I start subtracting first, then I'm going to get it wrong. Yeah, I was right. Okay, so then I'm going to subtract 605 minus 525. I get 80 cents. I get 20 cents. Remember, it's always positive because it's mean absolute deviation. So then I add up my differences. And then I divide by 5. So I got 0.44. So that's my MAD. Okay, so now I'm going to check the other side. So 775 plus 680 plus 825 plus 750 plus 675. I got 3705, so I'm going to add them again. Yep, and I'm going to divide them by 5, and I get $7.41. So now I'm going to subtract them all. And remember, it's always positive. Then I'm going to add up these 5 numbers. This is very time consuming. Yep. Okay. Then it says Taylor's mean absolute deviation is approximately 5 cents higher. So Taylor's is higher, Abby's is not. Taylor's mean, okay, let's subtract the means. 7.41 minus 6.05 is $1.36. That's not true. Taylor's is not lower, Abby's is lower. Taylor's mean is equal, that's not true, so it's gotta be A. All right. So if you have any questions before you retake, please let me know. I hope you have a great rest of your day. Bye.